These two aquariums came from the same vision model, DeepSeek V4 Flash Vision Exp. The earlier one ran through Hermes. This new one ran through DeepSeek's own harness. At first glance, the new tank has atmosphere, depth, and a coherent interface. But the question is not whether one frame looks better, it is whether the artifact holds up when the agent's own report meets independent inspection. DeepSeek Harness is the orchestration layer that manages the model's turn, tool calls, permissions, and workspace. This run used Harness version 0.1.1 RC.2, the DeepSeek official provider, workspace write permission, and the exact model ID DeepSeek V4 Flash Vision Exp. Both runs used Three.js 0.179.1, Vite 7.1.3, and no human source edits. But this was not a clean harness-only experiment. The prompts, browser route, tool schema, stopping protocol, and recording coverage were different. So every conclusion here is about these two run configurations, not a universal ranking of models or agent frameworks. The scored harness run finished with exit code 0 in 2,527,062 seconds, about 42 minutes and 6 seconds. The saved trajectory contains 143 completed reasoning steps, 149 tool calls with 149 matching results, and 24 successful image reads. The model produced 17 scored source files and 33 workspace images. Those numbers describe activity, not quality. Also, the earlier Hermes count of 131 model turns is not the same unit as 143 harness reasoning steps. I will not turn that mismatch into an efficiency claim, and there is no stored cost field, so there is no cost comparison here. The model did use Vision repeatedly, saving screenshots as it revised the aquarium. Its later captures show a recognizable underwater scene, 5 visibly different species, fog, light shafts, plants, hardscape, and a consistent bottom toolbar. They also show the limits. Several fish are strongly faceted, bodies overlap in the center, plants read as neon lines. The substrate edge looks like a slab, and the oversized top light dominates some compositions. These are the model's own captured views, not independent scoring frames. A fresh production build then ran in isolated Chrome without editing the scored source. The page returned HTTP 200, WebGL loaded and kept animating. The initial state showed 32 fish and 26 objects. Ordinary controls added one of each species, taking the fish count from 32 to 37. New Tank regenerated the scene and restored 32 fish and 26 objects. Explore, feed, place, and stone selection changed visible states. No fatal JavaScript, module load, shader, or WebGL failure was observed in that smoke test. The independent build also passed, transforming 32 modules. The later human playtest also confirmed that fish and object add-remove controls behaved acceptably. That proves a working production artifact and specific interactions, not correct feeding motion or every canvas behavior. Source inspection found 2 high severity issues. Object move can reuse a stale ray, so a click may move an object to the wrong point or fail. Schooling uses the wrong temporary vector when steering fish toward the group center. Food and environment animation updates are also disconnected. The later human playtest exposed the clearest visible failure. After food was dropped, several fish thrashed like stranded fish or repeatedly circled the same area. The behavior persisted until New Tank reset the scene. Dense frames from 43.5 to 79.5 seconds support the timing and persistent crowding. The motion judgment comes from the continuous human recording. Orbiting also revealed an opaque rear wall, preventing a complete all-around view, and the reviewer found the lighting weaker than the earlier version. For this run, the human verdict was not mixed. The reviewer preferred the earlier Hermes version overall. The harness artifact was production buildable, more modular, and capable of adding and removing fish and objects. but its closed rear blocked a complete all-around view. Its lighting felt weaker, and feeding could push fish into persistent thrashing or repeated circling until reset. The earlier run had problems too, and the two workflows used different prompts, tools, permissions, browser routes, stopping rules, and measurement units. So this is a run-level preference, not proof that Harness itself caused the lower quality. This is not a universal verdict that DeepSeek works worse in its own Harness. For this run, however, the human reviewer preferred the earlier Hermes artifact. The official runtime still carried the same vision model to a substantial working build, while screenshots and a clean build missed important behavior. For agent-built visual software, done should require 3 separate gates: the agent's own inspection, an independent production run, and targeted checks of the interaction code. Here, the first 2 looked encouraging. The third is where the aquarium became more interesting.